Hi guys, welcome to the fourth video of module 9, and here we're going to talk about the convolution operation. We're going to start by understanding about how the input image is going to look like, then what is the whole idea of filters, or you can also call it as kernels, then what is the meaning of strides and padding, and how all of these kind of things are going to help us understand the convolution operation. So yeah, that's also what we are going to talk about, that how exactly the convolution operation works depending on all the things that we have looked into. And after that, how the output of the convolution operation is going to look like after performing the convolution operation on the input image with the filters. So let's get started. So let's get started with the convolution operation. So what is the whole idea of the convolution? Just like what we had seen in our previous module, that we are having the weights and the biases. Over here also you have weights and biases, but the form of the weights and biases are a little bit different. So before I explain about how does the weights and the biases play important role in the convolution layer, let me first explain it to you in a proper way that what exactly happens in the convolution operation. So if you have ever dealt with the digital image processing, you must be aware about this thing. Or it's for even if you're a beginner, let me explain it to you in a very easy terms. Let's say you're given an image, and if I ask you to blur this image, how will you do it? You will be requiring a particular filter that's going to make that happen. Just like that, if I ask you to detect some kind of patterns from an image, whatever is the pattern that you're looking forward to, let's say what are some different kind of edges present in an image. For that, you need edge detector filters, right? You need edge detecting filters. You apply the edge detecting filters on the image and it's going to give you all the edges. For example, if you have used Snapchat filters, Instagram filters, they already know that this kind of thing should be the output. So for that, I need to pass in this kind of filter to get that output. If it's, let's say, a black and white image, if it's a blurred image, if it's going to highlight some kind of edges in an image, all of them are having its respective filter to get that thing done. Now over here, what we are doing is, we don't really know what kind of filter we need to give as an input. We just give in random filters with random numbers. Okay, over here, it's going to detect the vertical edges because that's how this particular thing is designed. 1, 1, 1, minus 1, minus 1, minus 1, and then the 0 in the between. It's going to give you all the vertical edges present in an image. But initially over here in a CNN, if I specifically talk about the convolution 2D layer, initially filters are given some random values over here. And then in the forward propagation, it's going to give you some kind of output. Let's say, for example, a horse is present or if a horse is not present. Then depending on how it is performing, it's going to do the back propagation. And during the back propagation, it's going to update the weights of this filters. Initially, I told you that all of these values are random. It's not 1, 1, 1, 0, 0, 0, minus 1, minus 1, minus 1. Let's say completely different values. Instead of 1, you may have, let's say, minus 0.83. Over here, you are having 0.23. Over here, you are having 102. Something completely random you can. The whole point in the back propagation, you have already learned about that. That is that you always, okay, you always learn what kind of optimal values can go over there with the help of some kind of optimization technique. So I hope you are able to understand what are weights over here. Just try to think about it. If you have really understood your previous module in a good way, you would be able to answer over here that the numbers that you are going to use in order to fill up this whole filter, these numbers are nothing but the weights associated to that filter. Now, each filter can also have a bias that you can pass on as an extra piece of pixel that you can add. I'll again show this kind of example in the upcoming few videos. But I hope that this whole idea of weights is clear. Initially, filters are completely blank or completely random. That's what I should say. And in this process of learning, during the back propagation, it comes up with the optimal value. Until it don't come with the optimal value, you will keep on doing the train. Right? So that's the whole idea. Cool. So now that we have understood that why do we require convolution operation, now let's figure out how does it actually works. So what we do is whatever kind of filter that you are having with some different random values, you take that filter and put it on the top left corner of the input image. Okay, this is slightly towards the right, but just assume that this red line is nothing but the boundary of your filter. Just shift it 1 unit to the left hand side. So wherever it will be, that is the first location where you are going to have your convolution operation between the input and your filter. How is it going to work? It's going to perform element wise multiplication. That is, 1 will be multiplied with 4, then 0 will be multiplied with 9, minus 1 will be multiplied by 2, 1 will be multiplied with any number that is over here that is hidden behind this arrow, then 0 will be multiplied with 6, minus 1 will be multiplied with 2, 1 will be multiplied with 2, 0 will be multiplied with 4, and minus 1 will be multiplied with 5. Whatever is the answer that you get, over here, let's say we are not having a bias. Okay, we are just having this filter without a bias. Then the output you're going to get, you're simply going to put it on the respective pixel. That is on the top left part of this output. Okay, this is the output that you are trying to fill with the help of this convolution operation. Just like that, if you just slide this window of a filter by 1 unit to the right, you can again do this kind of operation, the element wise multiplication. Do 9 times 1, 2 times 0, 5 times minus 1, 6 times 1, 2 times 0, 4 times minus 1, then 4 times 1, 5 times 0, and 4 times minus 1. Whatever is the output you are going to get, that is going to be 6, and that will be placed onto its respective location, that is 1 unit to the right of the previous value. And you keep on sliding this to the right. Let's say once you are at the end over here, you will shift your filter 1 unit to the bottom and again start from the first column. That is, you will start from this. This is the boundary that I am talking about. And this value will be filled over here. Like that, again you slide 1 unit to the right, and whatever is the output you will be getting, you will be filling it up over here. So that's exactly how the output is going to be filled with. You can take this example. You can try to just think about what will be the output of the convolution for this 478921384 with this filter and where you're going to fill it. The answer is whatever is the convolution you are going to do, you are going to do 4 times 1, 7 times 0, 8 times minus 1, 9 times 1, 2 times 0, 1 times minus 1, 3 times 1, 8 times 0, 4 times minus 1, and you are going to put it into the bottom right corner. So this is how a convolution operation works. Now, what do you mean by this size, stride, and padding? Well, I'll be talking much more about the stride and the padding. Why do we need it? What's the importance of having a stride and a padding? But let us first talk about what is the meaning of a stride. So this sliding of a filter that you are doing by 1 unit is what is called as a stride. I can control the stride by changing the value of stride as 2 over here. If I'm using stride is equal to 2, instead of skipping 1 column, I'll be skipping 2 columns to do the convolution operation. After that is done, I'll be again skipping the 2 columns and go to the right. Let's say if I cannot go to the right, I'll go 2 units in the bottom part and then again start from the first column. Once that is done, I'll again skip the 2 columns and go to the next side. And that's how the thing goes. That's the meaning of the stride. Now, what is the meaning of padding? I'll explain that in the next slide, that is over here. You are seeing that extra layer of 0 we have added throughout the whole input image. The input image is highlighted in this light blue kind of color. And around the light blue color, you can see everywhere there is 0, 0, 0. So that's called the padding layer. Okay. So in this particular image, we are adding a padding layer of 1. But over here, there is nothing like that. And therefore, the padding value is set to 0. Now, what is the size? Size is what is the size of this filter or the shape of this filter? It's a 3 by 3 filter, and therefore this f is set to 3. It shows that it is a 3 by 3 filter. And this is the original shape of the image, that is 6 by 6. And the output that you're going to get is going to be downsampled. That is, over here, if you count, it's going to be 1, 2, 3, 4, 1, 2, 3, 4. So a 4 cross 4 output you are able to achieve from a 6 cross 6 input. And this is one important observation that you need to take. That is, if you are not having a padding layer on top of the input image, the output of the convolution operation is always going to be a smaller size image as compared to the image that you had passed in the input. And what's the logic behind that? You can see that we are replacing this 9 pixels over here with only one particular pixel. So all of these pixels are replaced by only one pixel. That's why we can see that overall output size is going to be less as compared to the input after the convolution operation. And now you can just take a quick look about this convolution operation GIF in order to understand that how it's really going to look like. You always start from the top left. It's not compulsory to have your kernel with let's say a 3x3 size. You can have multiple different size of kernels, and you can just simply, and these kernels are nothing but the filters. Okay, you can pass this kind of filters across the whole image to the right and then to the bottom. And if I ask you what is the stride over here, you can see that it's just skipping one column every time. So the value of stride is 1 for this. And also there is one padding layer on the input image, and therefore there is one padding layer also. And the size of the kernel, as you can see, is a 3x3, so the filter size will be 3. And the output, again you can see that overall, after adding a padding layer, the dimensions were increased from the input image, and therefore the output that you're getting over here is of the same size that you were having as your input image. So even though it's looking like the input image is giving you the exact same size output, it is because of that padding layer. Now I'll be talking much more about the importance on the padding layer later on, but I hope that that's the reason why we are saying that the input image is having the same size as the output image in this particular operation. So yes, we are done understanding the complete idea of the convolution operation. Now in the next video, we are going to understand about what are the importance of having strides and padding in our convolution operation. So I'll see you in that one.